Welcome to Lattice Development Conference 2024. This session will cover a vision solution with GMSL, with analog device and Lattice. Short overview on the speakers, you will see more on the next slides. Kenan Wang from Analog Device will present the GMSL benefits implementation and a lot of backgrounds about GMSL. I'm hosting this session, Karl Wachsmender, Senior Principal System Architect from Lattice. As I said, my name is Karl Wachsmender. I'm a Senior Principal System Architect in Lattice for the industrial segment. My position is worldwide, and I'm developing an industrial FPGA solution with the current and next generation FPGAs. Focusing on the industrial and develop the partnership between channel OEM customers and grow the network of the industrial customers. With me is Kenan Wang from Analog Devices. He is a system application engineer from the automotive cabin experience group. He is on the east side from USA based, and you see the degree of the Northeast University of Boston. He's a specialist in the 2D, 3D imaging side and covering hardware development, system development. I have seen also software development on his side, and he leads the implementation on the FPGA with GSML from the analog device side with Lattice. And now over to Kenan. Please take it away and the presentation on the GMSL side, and I'm looking forward to learn more from you.
Thanks, Carl, for the introduction. Now let's jump into today's topic, GMSL across markets, applications, system design, and ecosystem dynamics. Gigabit Multimedia Serial Link, or GMSL, is a highly configurable SerDes interconnect solution. It provides simultaneous transmission of real-time data, control, and power signals over a single wire. GMSL devices are designed to support two main use cases. One is for cameras and sensors. You'll find them in cars, surround view systems, backup cameras, and driver monitor systems. The other one is for displays, and they can be found in your car's dashboard, central display, or e-mirrors, etc. The GMSL technology has been widely adopted by the automotive industry, and in recent years we have been seeing an increasing number of multi-market, or in this case non-automotive market applications. Looking at the history of GMSL technology, from the first generation GMSL product, we already have more than 20 years of development and deployment history. Now there are 3 generations of GMSL product in production, from GMSL 1 to GMSL 3. In total, there are over 900 million ICs shipped for automotive customers, and we have more than 25 automotive OEMs all over the world using GMSL technology today. The key value proposition of GMSL is to reduce cabling or wiring infrastructure. As I mentioned in the previous slide, as a SerDes solution, GMSL can not only transmit data, but also bidirectional control and power signals simultaneously over a single wire. In addition, the GMSL SerDes have a variety of video interface to support different topologies required by the end applications. For example, we have camera serializer with 2 MIPI ports to support sensor fusion with 2 co-located sensors. The GMSL camera or sensor deserializer can support 1 to up to 4 serializers for MIPI data aggregation. Many of our GMSL camera and display devices will support sensor data replication for redundancy and duplication. This is used a lot in safety critical applications. And last but not least, video splitting, which is often used for display related applications. The GMSL devices support high-resolution video transmission. GMSL2 devices modulate with 3 or 6 gigabit per second data rate and can support video payload up to 2.6 gigabit per second or 5.2 gigabit per second. And they are often paired with sensors up to 8 megapixels or 4K or less displays. GMSL3 devices modulate at 12 gigabit per second data rate and can support video payload of up to 9.6 gigabit per second, and they are usually used with image sensors greater than 8 megapixels or 4K plus displays. When you start your design with GMSL devices, you'll find it's very scalable. Most of our devices are one generation backward compatible, and you can very easily find pin compatible options for 3, 6, and 12 gigabit per second options. For safety and security, the GMSL link has a deterministic latency in microseconds with very low bit error. The GMSL 2 and 3 devices have real-time adaptive equalization to make sure the link works with changes in their environment. The GMSL SerDes also have many built-in features to support link diagnostics, data integrity checks, including for the video interface as well as the SerDes link. All GMSL devices are designed to meet stringent EMI/EMC requirements from automotive OEMs, and for every generic product, you will find ASIL-B functional safety rated options. Here is a summary of some key technical features of GMSL2 and GMSL3 devices. GMSL2 links operate in asymmetric full duplex mode. We usually refer to the serializer to the deserializer channel as the forward channel that will carry video data and higher bandwidth signals. And the other direction we refer to as reverse channel with lower bandwidth. Most GMSL devices support low-frequency GPIOs, I2C, UART, and SPI tunneling, and some display devices also supports I2S or PDM as an audio interface. The power over coax feature provides remote power to the sensors to future reduce external power cabling requirement. The power handling capability is usually restricted by the current ratings of the inductors used for the POC network, and the total power carrying capability will depend a lot on the voltage ratings of the system. We have recommended POC network to support up to 3 ampere of current. In a 12-volt automotive system, this translates to more than 30 watts of power. The GMSL 2 and 3 links have an adaptive equalization feature. It automatically adapts the equalizer setting from the transceiver every second. So if your system starts from cold and run in hot environment, you don't have to worry about the link loss because of the initial setting is wrong. In newer GMSL2 and GMSL3 devices, we introduced tunnel mode for sensor data tunneling. In this mode, the link will not modify the MIPI packets from the sensor at all. As a result, the MIPI data reaches the SoC is exactly the same as what sensors send out. This includes data types, word count, and most importantly, the CRCs. This feature further improves end-to-end data integrity. As mentioned in the previous slide, GMSL2 and 3 SerDes are all ASIL-B qualified, which is equivalent to SIL2 in some industrial applications. GMSL devices have comprehensive error monitoring, diagnostics, and reporting features to help functional safe design on the system level. The new GMSL2 and GMSL3 devices also offer a reference clock over reverse channel feature, or ROR, when you check some documents. So this means the serializer can generate a reference clock signal from the GMSL link from the deserializer. This helps remove an external oscillator for both the serializer and the image sensor to further reduce the BOM cost and to shrink the board space. When using multiple sensors in aggregation mode, this will also guarantee the drift of all reference clocks are moving in the same direction. GMSL2 devices use NRZ modulation and GMSL3 devices use PAM4 modulation. As a result, GMSL3 doubles the GMSL2 bandwidth while maintaining the same modulation frequency. This can further improve the backward compatibility and let the customer to maximize their hardware reusability. In the past, GMSL2 devices are all hidden behind NEA, and we have selectively picked some products to fully release them online. For camera and sensors, we have a single input and a dual input serializer, and on the deserializer side, we have deserializer options that can connect to 1, 2, or 4 GMSL2 links. For sensors and camera applications, GMSL devices are very flexible on what's in the front end, as long as it has a MIPI output that goes into a serializer. Most common use cases are with a single RGB sensor, but it can also be a time-of-flight sensor, a LiDAR or radar front end with a MIPI interface, or anything goes through a dedicated ISP chip with MIPI output. For camera applications, coax cables are often used by default with power over coax feature. But in some cases, shielded twisted pairs are preferred, especially when the link has to be twisted or bent a lot. The camera or sensor deserializers can connect up to 4 GMSL links and send out data through their MIPI transmitter to an application processor with configurable lanes and C-PHY D-PHY options. This year, we have also released the GMSL2 display SerDes pair, a HDMI serializer and an OLDI deserializer. The display devices have more interface options compared to camera devices, and it's usually an SoC-friendly interface on the serializer side and a display panel-friendly interface on the deserializer side. Display applications sometimes have higher bandwidth requirements, and you'll see some GMSL display devices with 2 ports, including this GMSL2 pair we released online. These devices are very flexible in their video stream management. Each link can carry an independent video stream or work in a pair to transmit a higher resolution stream. The deserializer is also highly configurable to display the videos from 1 or 2 individual displays. As mentioned in the previous slides, GMSL was first designed for automotive applications. You will find GMSL links being used in various sensors and infotainment applications in the cars. For example, displays for drivers and passengers, e-mirrors, backup and surround view cameras, as well as driver and passenger monitor cameras. Today, we will also look at some application categories beyond automotive applications. The first category here is connected motion and robotics. This category includes autonomous mobile robots, or AMRs, collaborative robots, or cobots, and other types of robot, for example, delivery robots, agricultural robots, lawnmowers, home robots, and humanoid. In this category, there is a very strong demand using both 3D and 2D cameras for slam, obstacle avoidance, object detection, and fiducial mark or barcode reading for navigation. For cobot, there are GMSL display parts used for teach pendant, and there's an increasing number of industrial machine vision cameras with GMSL device serving these robots from outside of the arm. For robotics customers, people prefer to use GMSL-enabled cameras because of they interface directly to the MIPI receiver on the SoCs and provide an efficient way to aggregate multiple cameras. Since GMSL is a proven technology for automotive customers and products are ASIL-B rated, it's easier to design a functional, safe system with GMSL devices. Compared to many legacy solutions based on Ethernet and USB cameras, GMSL cameras are often paired with coax cables and factor connectors used in automotive applications, and these are more stable and reliable. In the long run, it will lower the overall robotics maintenance cost and the operating downtime. There are also some challenges we see in this market. Sometimes robotics customers don't have embedded system knowledge to port in a camera driver. And sometimes there are special requirements, for example, powers that are not typical for traditional automotive use cases. We are trying to help solve these problems by generating reference designs and application notes, as well as leveraging help from our ecosystem partners. Next category is industrial vehicles. These are the vehicles that are not usually considered as automotive, but for most of the use cases, they have similar requirements as automotive or passenger vehicles in this case. This includes smart agriculture machines, for example, sprayers machines, harvesters, tractors, and produce sorters. For these applications, cameras are used not only for driving assistance, but more for functional use cases such as object classifications and color sortings. For other non-passenger vehicles, including heavy-duty construction machinery, public transportation such as buses and trains, and recreation vehicles including RV, bikes, and golf carts, GMSL cameras and displays are often used with the same use cases as they are used in passenger cars. In this category, people choose to use GMSL because they want to leverage learnings from automotive, reduce cable infrastructure, and enjoy low bit rate, low latency, as well as automotive functional safety. One big difference from automotive is in this category, there is a very diversified ecosystem. There are many smaller and new players in both the supply chain and OEMs. Some equipment or cars are highly customized, and sometimes these cameras or displays are post-installed, so the requirements sometimes can be difficult to summarize from the OEMs themselves. Intelligent infrastructure used to be dominated by IP or analog cameras and their corresponding DVR boxes. Reacting to the video feed is not easy. It often requires a human look at the video stream live or post-processing the data from a server. GMSL-based cameras are smaller, less intrusive, and can more easily fit into applications in cramped spaces or have privacy concerns like ATMs, elevators, restaurants and shops, etc. For smart infrastructure, we have seen GMSL cameras designed in traffic camera systems or used for inventory monitoring in shops and warehouses. Compared to the legacy solution, people use GMSL-based solution together with some newer SoCs to make real-time decisions and trigger events immediately when necessary. For some applications, GMSL also provides benefit to efficiently aggregate multiple cameras, and for those outdoor applications, GMSL provides benefits to operate through harsh environment. In this application category, we sometimes face challenges to fit GMSL into existing ecosystem. For example, some infrastructures have pre-routed cables that are too lossy to support GMSL, which makes adding a GMSL camera less straightforward. But with the newer design, where we can plan from the beginning, this would be less of a concern. For aviation and unmanned area vehicle, or UAVs, GMSL technology is used for both in-cabin and external use cases. In-cabin, we see use cases such as cockpit monitoring, cabin surveillance, and passenger or cockpit display. External applications are mainly cameras with different use cases. For example, collision avoidance, landing assistance, and area scanning and mapping. For these applications, our success in automotive market gives people confidence for GMSL's reliability, including low bit error rate video transmission and system-level mechanical reliability. Lightweight cabling is also a big benefit. For some highly integrated solutions, GMSL's configurable video aggregation and distribution features also make the system architecture easier. Sometimes these applications require extended cable length and have more stringent qualification process that are less open to the general public. There are some off-the-shelf GMSL repeaters and lower loss cables to help extend the reach of the GMSL links, and we are also trying to better understand system-level qualification requirements and regulations to help with a broader customer base. For digital healthcare applications, we see GMSL devices being picked up for both cameras and display use cases in surgical robot to provide immersive display experience and machine vision in and around the robots. In addition, there are also GMSL-enabled surgical endoscopes being designed for both surgeons and surgical robot use case. In some patient support use cases, GMSL cameras are picked up for continuous patient assessment and telemedicine for its reliable video transmission capabilities. In this category, GMSL provides benefits in form factor and power consumption reduction. For example, in the surgical endoscope use case, compared to the traditional optical-based solutions, GMSL endoscopes will allow surgeon to hold the scope for longer time without feeling hot or fatigue. For digital healthcare applications, especially for surgical endoscopes, isolation is a topic often got brought up. The isolation include isolating the patients from high voltage devices and isolating the GMSL link from other high voltage and high frequency interferences. We are actively working on some reference solutions to better address these issues. Here are some other applications that we see adoption or see some potential for GMSL technology to be adopted. This includes automated test equipment or ATEs for ICs, automotive cameras, and automotive displays. Product inspection equipment, like the second picture here, showing a conveyor belt type of application. Scientific instruments, for example, for digital microscopes, there are many GMSL-enabled microscopes. Tethered AR and VR headsets. This is for both consumer or enterprise use. Body cameras for sports and law enforcement And in the wearable category, we also have a area mapping equipment, like those backpack form factor cameras for people to walk into spaces that the cars are not able to get into. And some other applications include industrial endoscopes. The idea is similar to healthcare endoscopes. And then aquaculture, and people use GMSL based cameras because it's can live through harsh environment. If you look at all these opportunities we went through, there are applications that are easy to adopt GMSL and others can be more challenging. GMSL devices always come in pairs. If GMSL is already selected for one side of the application, it has to be used on the other side as well. This applies to all automotive applications. When the OEMs choose to use GMSL technology, the Tier 1s will have to provide GMSL-enabled components for both cameras and displays, and on both sides of the systems. Very similarly, if people have to build test equipment for devices with a GMSL interface, they will need GMSL devices built into their own equipment. Some applications are trying to leverage automotive use cases. For example, the AMR vision system requirement can be very similar to the ADAS vision system requirement, and the infotainment for avionics can be very similar to the infotainment systems in cars. In these cases, it's not that difficult for the system architect to make decision to adopt GMSL. Because the parts and architecture have been validated by automotive industry for many years. For some emerging applications, including endoscopes, surveillance cameras, wearable cameras, and headsets, GMSL does offer unique value in the system design, but the system requirement might be different from the traditional automotive use cases. And in some cases, it means it needs more time to validate a slightly new system in the early development stage. Last category here is to use GMSL for general purpose machine vision solutions, which means to add GMSL to the existing popular machine vision interface portfolio, such as USB, Gigabit, and CoExpress. The requirements for these type of cameras are varied due to its open-ended nature for end applications. However, we started to hear some machine vision providers adopting GMSL as a new interface option. For applications like this, compatibility with other legacy solutions is a key, and this has to be enabled by the machine vision providers. Now we have learned GMSL products, history, and targeted applications. How do we get started? As I mentioned earlier, we have open released those roadmap products online, which means the data sheets, evaluation kits, user's guide, channel specifications, hardware design guide, and a GUI tool are all publicly available online to help with your design and debug. We also have a growing FAQ hub on ADS Engineer Zone, as well as a newly launched GMSL University offering self-paced training modules that are grouped into different levels and training tracks. On Analog Devices GitHub page, we share some reference software drivers for select GMSL products and links to wiki pages that go over how to bring up our in-house developed solutions. We understand the importance to have a robust ecosystem and are also grateful that there are many ecosystem partners already providing product and services today to help the end customers design in their GMSL solutions. If you look at the GMSL camera signal chain, for example, Our ecosystem partners usually provide modular camera solutions with different combinations of lenses and sensors plus GMSL interface. There are also some more integrated camera or sensor options provide an all-in-one feature-rich design with GMSL output. On the deserializer side, there are various platforms to choose from to support quick system prototyping using GMSL-enabled adapter boards to a reference SoC platform, or a PCIe or Gigabit Ethernet adapter board use GMSL with an x86 PCs. There are also some heavier duty ruggedized industrial PCs with GMSL input ports to help people deploy GMSL cameras in harsh environments. Now if you go to analog.com GMSL solutions page, you will find a logo wall with our partners in GMSL ecosystem. These companies range from silicon vendors, cable and connector suppliers, design houses, and test solution companies. Our partners have the expertise to help with the GMSL system design and validation, from hardware PCB simulation and validation, camera driver creation, ISP tuning, and system integration, and can offer help from the prototype stage all the way to the deployment stage. As we explore and expand the market reach, we hope to see this list keep growing. This year at LDC, we will be demonstrating a camera system using GMSL SerDes solution and NVIDIA Holoscan sensor bridge enabled by Lattice. With this solution, we'll be able to expand our reach to a larger customer base for applications that needs edge intelligence. That's all for my presentation. Now let's move on to the Q&A section. The first question here, why GMSL in industrial applications? As I mentioned in the slides, GMSL is a proven technology by automotive industry with stringent environment. If you see the industrial applications, many of them have similar system or requirements or camera or display link requirements. Leveraging the learning from high volume applications like automotive will make the adoption easier and smoother for industrial applications. The second question here is, what are the benefits of GMSL compared to Ethernet? Compared to Ethernet, GMSL solution in general is lower power and lower cost with the same data rate tier. Aggregating multiple GMSL cameras and enabling power over coax is simpler than doing it using Ethernet. GMSL provides a direct access from MIPI to MIPI interface, which means from the sensor MIPI to the SoC MIPI, which is ideal for many camera applications with embedded SoCs. Next question, how to connect GMSL to a system with Ethernet backbone? Using an FPGA is a common solution here. A good example is the Holoscan sensor bridge from Lattice, and we have that demo for the LDC this year. This solution is essential for applications with a host platform that doesn't have direct MIPI input. The last question here is, what is the max data rate? The max data rate for GMSL2 and GMSL3 devices are 6 and 12 gigabit per second. You can refer to slide number 7 or the GMSL device datasheet for more details.